What's up, geometry? Thanks for tuning in for another episode of Math with Mullins. Today we're looking at part 2 of our lesson 3.5, equations of parallel and perpendicular lines. And our main goal is to be able to use slope to be able to find that distance from a point to a line. The 3 steps we're going to use, and these kind of take a little bit of time, so you just have to be patient with them. In order to do that, to find the distance from one point to the line that is given, first we find the equation of the line perpendicular and through the point. So we're going to use point slope form and making sure that we have that perpendicular slope guaranteed. Then we're going to use that original equation and new equation to solve the system to see where they intersect. This is when we're going to substitute for y and set it equal to the new equation. The last thing we'll do is use the distance formula by plugging in those new points and the original point to find the distance of those items. This is already included in your notes, but if you needed to take time now to pause the video, I would do that. Otherwise, if you're ready, let's keep going. So what we're going to do is we're going to start here. It says find the distance from point 1, 0 to the line y is equal to negative x plus 3. And what I'm going to do is as we show our work, I'm going to number it 1, 2, and 3 so you can know where I'm matching up those steps. So step 1 is to solve by finding the line perpendicular through the point. So the first thing I need to know is what is my perpendicular slope to the equation y is equal to negative x plus 3. The perpendicular slope I'm going to use is a positive 1. Okay, so then I will use that to write my equation with the slope of 1. Y minus y1 in point slope form equals m parentheses x minus x1. You can still do slope-intercept form here, but I find point slope form is a lot easier. Y minus y1 is actually just y because y minus 0 just be y. My slope is 1 parentheses x minus 1. As I reduce that, I'm going to get y is equal to 1x minus 1. So this is my new equation. Remembering that my original equation is y is equal to negative x plus 3. I'm going to set these equal to one another to try to solve for x. So negative x plus 3 is equal to 1x minus 1. I do that by combining like terms and putting them on the same side as one another. So I get negative 2x is equal to negative 4, and then x is equal to a positive 2. Now that I know this, I'm going to plug that back into the original problem to see what y would be equal to. So y is equal to negative 2 plus 3. That means y is equal to 1. So my new point will be 2, 1. So they intersect at 2, 1. Okay, so here's 2, 1. Now, I want to know the distance between the original point and this point. So I just did step 1. Here is where I did step 2. Step 3 now is going to be using the distance formula. Okay, so I'm going to use these 2 points, 1, 0 and 2, 1 as my x1, y1, x2, y2. Okay, so that means I'm going to do 2 minus 1 squared plus 1 minus 0 squared. 2 minus 1 squared is 1. 1 minus 0 is 1. I'm squaring those both equal to 1. So that's the square root of 2, which is approximately 1.4 to the 10th decimal place. Here we go. For our next example, if you want to pause the video and try this on your own, doing the same steps we tried, otherwise, let's get started. The first thing we want to decide is the perpendicular slope. So the perpendicular slope is going to be negative 1. So now I'm going to use my point slope form, y minus y1 equals m parentheses x minus x1 to write that new equation. Y minus 4 equals negative 1 parentheses x minus 6. Combining like terms or distributing, I'm going to have negative 1x plus 6, and then I'm going to add 4 to both sides. I get y is equal to negative 1x plus 10. Here is my new equation. So now that I have my new equation, I'm going to take my original equation of y is equal to x plus 4, orig, and set them equal to one another. Now we're going to move into step 2. X plus 4 equals negative 1x plus 10. Let's go ahead and move the numbers to the same sides. I'm going to add 1x to both sides and minus 4 from both sides. So x plus 1x is 2x, 10 minus 4 is 6, x is equal to 3. I'm going to take this and plug it into my original question. Y equals 3 plus 4 means y is equal to 7. So my intersect point is at 3, which is my x value, comma 7, which is my new y value. Now I'm ready to find the distance of those points. x2 minus x1, so I'll say this is 6 minus 3 and 4 minus 7 for my y's. 6 minus 3 squared plus 4 minus 7 squared. I got 6 minus 3, that's 3, so 3 squared is 9. 4 minus 7 is negative 3. Negative 3 squared is also 9, so I get 9 plus 9, which is the square root of 18, and that is going to round to about 4.2. Okay. Example 3, this one does get a little crazy because you're going to have some decimals or some fractions, so just be okay with that. I will also recommend how to change a fraction to a whole number, and you can try that as well. First things first, what is the perpendicular slope? So step 1, the perpendicular slope for negative 2x is a positive 1/2. So let's use our point slope form. Y minus 6 is equal to 1/2, parentheses, x minus x1 would be x minus negative 1, which is actually x plus 1. Okay, now I'm ready to get y all by itself after I distribute. So let's do that first, actually. Y minus 6 is equal to 1/2 x plus 1/2. Then I'm going to add 6 to both sides. Okay, now I am going to get a fraction here, 6.5 or 13/2. Or you could even make it to be 6.5. I'm going to do something kind of a little crazy with that. Okay, so that's my new equation. Now I'm moving into step 2, which is using my original equation of y is equal to negative 2x and setting it equal to my new one. So negative 2x is equal to 1/2 x plus 6.5. I'm going to subtract 1/2 x from both sides so that I get negative 2.5x is equal to 6.5, and then I divide both sides by negative 2.5 or negative 2.5, and I get x is equal to negative 2.6. Okay, I'm going to take this x coordinate and plug it in to my original problem to find out what my y is equal to. So y is equal to negative 2 times negative 2.6. That means y is equal to a positive 5.2. So my new point is where they intersect, negative 2.6 for x coordinate and positive 5.2 for my y coordinate. Now I'm ready to do my distance, and this is going to be my step 3. x2 minus x1, y2 minus y1. So let's say negative 1 is my x2 minus x1, y2 minus y1. Okay, I'm going to have negative 1 minus, I don't know why I did another radical, negative 1 minus negative 2.6 squared, which will actually end up being plus, and then 6 minus 5.2 squared. Okay, here we go. Negative 1 plus 2.6, that is going to give me a negative or positive 1.6. So I'm going to have 1.6 squared plus 6 minus 5.2 is 0.8 squared. Okay, 0.8, let's start there, times 0.8 is 0.64. 1.6 squared times 1.6, that is 2.56. So now I'm going to add those together. I get the square root of 3.2, and that's about 1.8. Okay. Last one, finding the distance from the point 6, negative 2 to the line 2x minus 4. perpendicular slope is first. Step 1. Perpendicular slope would be m equals -1/2. Okay, so let's do my point slope form. Y minus -2 would be y plus 2 is equal to -1/2 parentheses x minus 6. Okay, let's distribute. I get -1/2 x plus 3. That is now ready to solve for y. Subtracting 2 from both sides, y is equal to -1/2 x plus 1. This is my new equation. Now I'm going to take my original equation, 2x minus 4, and this is going to start my step 2. Set them equal to one another to find my x value. 2x minus 4 is equal to -1/2 x plus 1. I'm going to add 4 to both sides and add 1/2 x to the other side. Okay, I'm going to get 2.5x equals 5. Dividing both sides by 2.5, x is equal to 2. So that's my point that I'm going to plug into my original problem to get my y coordinate. So now that we know x is equal to 2, we're just going to plug that back in here to get our y value. So y equals 2 times 2 minus 4. 2 times 2 is 4, and 4 minus 4 is 0, so we're getting y is equal to 0. So the intersection point is going to be at 2, 0. Finally, we can use that for our step 3 of using the distance formula. We can say maybe x2, y2 are original points, and x1, y1 are the newer points. So we're going to do 6 minus 2 squared plus -2 minus 0 squared. 6 minus 2 is 4, and 4 squared is 16. -2 minus 0 is -2, but squaring that gives us 4. So now we're getting the square root of 20, which if we find the decimal equivalent, it's about 4.5. That is going to be all for our notes today. Thanks so much for tuning in and just being patient there. Hopefully these 3 steps help you understand how to find the distance from one point